So what if you're given a nuclear equation with something missing? Okay, well, the overall concept that we've been talking about is total mass stays the same on both sides of the nuclear process. So the parent nucleus is breaking into smaller pieces, but the overall mass is going to add up to be the same value that it once was. So if we have a uranium-235 that is turning into a helium and something else, this missing piece must weigh 231. If we know that the overall atomic number, so the overall positive charge in the universe was 92, and the helium is taking 2 of those 92s, then the leftover atomic number is 90. And on the periodic table, number 90 is TH. So what is this process? If we're looking at it, the uranium is spontaneously changing. So we know it's not fission or fusion. It has to be alpha, beta, gamma, or something else. Okay, it's spontaneously changing because nothing's being added to it. And one of the products being created is a helium nucleus. Well, that lets me know that this is alpha decay. So if we analyze this question and we're trying to fill in this blank, okay, what I'm going to look at first is the mass. This iron, the parent nucleus, has a mass of 55, and the daughter nucleus also has a mass of 55. So that means whatever this substance is here that I'm adding to my iron must have a mass of 0, because it hasn't affected the daughter nucleus at all. If we had 26 protons, but now we only have 25, that means we've reduced the value of these positive charges by 1, and the only way to do that is if you add a negative charge. So if we're keeping consistent with all these particles that we've been looking at, the only one that we've seen that has no mass and a negative charge is an electron. So now if I have to identify this process, I'm looking at what I'm seeing here. We've got an iron adds an electron to itself and turns into a manganese. The only process that we've looked at that does that is electron capture. Okay, so the electron is part of the original process, not a product, which is different from this process. So here we have a similar situation where the mass is 87, the mass is 87, so that means this has a mass of 0. Okay, but if this has 37 protons and this has 38, that means that we've increased in our overall positive charge, and we need to balance the universe. So that means that a negative charge must have also been produced by this process. And again, a 0, -1 is an electron. But the difference between this process and this process is the electron is a product, which means that this is, oops, that doesn't look like a B. This is an example of beta decay. So in this case, the electron is being produced by the rubidium, whereas in this process, the iron was using an electron to change. And our last example, what if you have to put it all together yourself? So what if you have to write the whole equation for potassium-38 going through positron decay? So we're going to start with the parent nucleus, so K38. And on the periodic table, potassium is always number 19. Okay, positron decay is always a product. So that means I can put my arrow right away. And I know that obviously one of the products that it's making is a positron, which has no mass and a positive charge and has the symbol of an E. So what I'm really solving for is what is potassium turning into? If this weighs 38 and this has no mass, then this stays 38. Okay, but here we have 19. We need the overall charge to be 19. So if this has a +1, then this must have 18, which means